guys, so today I will be talking about the tangent line. But before that, allow me to define what is tangent line. So a tangent line to a curve at a given point is a straight line that just touches the curve at that point. Mathematically, if you have a function f of x and you want to find the tangent line at x equals a, you use the derivative f prime a to get the slope of the tangent line. Let's have an example. Find the equation of the tangent line to the curve f of x equals x squared at x equals 1. We have to solve the values of f of a and f prime of a so that we can plug them into it. So first, f of a, we have to change a to 1 equals, it is 1 equals to 1 squared, and 1 squared is equal to 1. And for the f prime of a, we have to find the first derivative of x squared, which is 2x. So now, we get the f prime of 1 is equal to 2, and then we change the x to 1, so we have 2 times 1 equals to 2. And now we have the value of our f of a and f prime of a. So therefore, the equation of the tangent line is y minus 1 equal to 2, and x minus 1, which is given in our formula. So y equals 2, we just have to put the 1 to the end and make it positive. So we have y equals to x minus 2 plus 1. And then we get y equals 2x minus 1.
A normal line is a line that is perpendicular to a line tangent to a curve at a point of tangency. And when we say perpendicular, the two lines form a right angle. For example, if this curve is our function, then the point M is our point of tangency. And if this line is our tangent line, then our normal line is the line perpendicular to our tangent line, which is also connected to our point of tangency. The slope of a normal line is the negative reciprocal of the slope of the tangent line. And to find its equation, we can use this formula. The y minus y sub 1 is equal to negative 1 over m times the quantity of x minus x sub 1, where the x sub 1 and y sub 1 is our given point of tangency. Now, let's proceed to our example. Find the equation of the normal line to the curve of f of x is equal to x squared at x is equal to 1. We know that the slope of the tangent line is at x is equal to 1, based on the computation is 2. Therefore, the slope of a normal line is its negative reciprocal, negative 1/2. And using the point slope form to find the equation of the normal line, we get y minus 1 is equal to negative 1/2 times the x minus 1. Then we get negative 1/2 x plus 1/2 plus 1. We just simply change the 1 into the other side and change the sign from negative to positive. Then we add 1/2 and 1 since it has like terms, and we get y is equal to negative 1/2 x plus 3 over 2.
Hi everyone! Today, we're learning about concavity, a concept in math that helps us understand how a curve bends. Let's keep it simple and straightforward.
So what is concavity? Concavity describes the shape of a curve. A curve is concave up if it bends upward like a smile. It is concave down if it bends downward like a frown.
And why does concavity matter? Concavity helps us see how a graph behaves. It tells us if the slope is getting steeper or leveling out.
How to find concavity? To figure out the concavity of a curve, follow these steps. First, find the second derivative. Second, check if f of x is positive or negative in different intervals. If f of x is greater than 0, the graph is concave up. If f of x is less than 0, the graph is concave down. So let's try an example for f of x is equal to x cubed minus 3x. So the first derivative of x cubed minus 3x is 3x squared minus 3. And the second derivative of x cubed minus 3x is 6x. So let's test the intervals. If x is greater than 0, it is concave up. If x is less than 0, it is concave down.
To recap, concavity shows us if a curve bends up or down. It's easy to find using the second derivative.
A point of inflection is where the curve changes concavity. It occurs when the second derivative becomes zero or undefined. For example, is f of x equals x cubed minus 9x squared plus 7x. The first derivative will be f prime of x equals 3x squared minus 18x plus 7. The second derivative will be f double prime of x equals 6x minus 18. The second derivative will become 0. In order to find the point of inflection, you need to divide the first term by itself. 6x over 6 cancel out 6, so the x will remain. X is equals to 18 over 6. 18 divided by 6 is 3. X is equals to 3. That is the inflection point. The graph would be like this. This is the concave down and the concave up. This would be the inflection point. It is where the concavity changes.
Now, let's understand what is local maxima and minima are. A local maximum is a point where the function reaches a peak within a given interval, meaning the function value at this point is greater than the values of the surrounding points. Then, a local minimum is a point where the function reaches a trough, meaning the function value is lower than the values of the surrounding points. For example, f of x is equals to x cubed minus 6x squared plus 9x plus 15. So in finding the local maxima and minima, we need to follow these following steps. We need to find the first derivative of our function, which is the f of x is equals to x cubed minus 6x squared plus 9x plus 15. So the second derivative is 3x squared minus 12x plus 9. Then, set the first derivative to 0 and solve for x. 3x squared minus 12x plus 9 is equals to 0. Since our second derivative has a coefficient of 3, we need to divide our function to 3. So the answer is x squared minus 4x plus 3 is equals to 0. We need to factor x squared minus 4x plus 3 so that we can easily solve for x, which is x minus 3 and x minus 1 is our x. So the x minus 3 and x minus 1 is we need to evaluate at with 0. So the step 3 is we need to find the second derivative of our functions, which is 6x minus 12. And then we need to evaluate the second derivative at the critical points, which our critical point is x is equals to 3 and x is equals to 1. Since we find the second derivative, we need to substitute our x. In finding our local maximum, we need to substitute our critical point to our second derivative, and the answer is negative 6. Since f2 prime 1 is less than 0, the function has a local maximum at x is equals to 1. The second critical point is at x is equals to 3. Just substitute it to our second derivative and the answer is positive 6. Since f2 prime 3 is greater than 0, the function has a local minimum at x is equals to 3.
Now let's identify the maximum and minimum points using the first derivative test. In the first derivative test, it states that if the first derivative changes from positive to negative at x is equal to c, then f of c is the local maximum. And if the first derivative changes from negative to positive at x is equal to c, then f of c is the local minimum. For example, is the function f of x is equal to x cubed plus 6x squared plus 9x plus 15. First is we need to find the first derivative, which is 3x squared minus 12x plus 9. Then, we need to equate the first derivative to 0 and solve for x to get the critical points, which would give us this answer. And since we have two critical points, we need to clarify these points individually. First is the point x is equal to 3. We need to plug in a number that is greater and less than 3 to the first derivative to find whether it is the local maximum or minimum. As you can see, as I plug in those numbers, you've noticed that the point x is equal to 3 is the local minimum because the first derivative changes from negative to positive. Next is the point x is equal to 1. And as you can see, as we plug in those numbers to the first derivative, you can see that the first derivative changes from positive to negative. Therefore, point x is equal to 1 is the local maximum. Therefore, in the function f of x is equal to x cubed minus 6x squared plus 9x plus 15, the local maximum is x is equal to 1 and the local minimum is x is equal to 3.